All right, from your projectile question sheet. Number 1 says a pitcher throws a baseball horizontally and lets it go when it's 2 meters above the ground. Okay? But of course, as it travels, it goes down. So it ends up getting to the batter. When it gets to the batter, it's 0.5 meters above the ground. And it wants to know, it says the distance from the batter to the pitcher is 20 meters, and it wants to know what's the speed that it was thrown with. So in the x direction, we're looking for VIX. It's a horizontal projectile. We know AX is 0, and we know delta dx is 20 meters. We do not know delta t. In the y direction, we know VIY is 0. We know AY is 9.81 meters per second squared. And you have to do some higher order math here. But if you do, you'll get your delta dy, so I think I already hit that there, to be 1.5 meters down. And we don't know delta t. Okay, and so when you look at it, it's like, oh, I need to start in the y direction. So in the y direction, we know delta dy is equal to VIY delta t, 1/2 AY delta t squared. The VIY goes to 0, multiply both sides by 2, divide by a, and you get 2 delta dy over AY. So delta t squared is equal to 2 times 1.5 meters over 9.81 meters per second squared. Don't forget to take the square root, and when you do, you get a time of 0.553 seconds. Once you have that time, then you go to the x direction. Delta dx is equal to VIX delta t, 1/2 AX delta t squared. This term goes to 0. You're looking for VIX, so it's just equal to delta dx over delta t. So 20 meters divided by that 0.553 seconds we just found, and we get a VIX to be 36.17 meters per second. Number 1, done. Number 2, Throckmorton, back by popular demand, jumps off a high diving board with a horizontal velocity of 2.8 meters per second. So he dives out with a VIX, and then he goes down to the water. So in the x direction, it tells us the VIX is 2.8 meters per second. And of course, we know the VIY is 0. The AX is 0. And the AY is 9.81 meters per second squared. And then it says it takes him 2.6 seconds to hit the water. So delta t is 2.6 seconds, and delta t is 2.6 seconds. And it wants to know what's delta dy, how high, and how far out. So really, this one's a gift. Part A, how high is the platform? Delta dy is equal to VIY delta t plus 1/2 AY delta t squared. This goes to 0. You don't even have to rearrange. Delta dy is 1/2 9.81 meters per second squared times 2.6 seconds squared. Assuming you remembered to square that time, you should get 33.1578 meters for the height of the diving board. Part B wants to know how far out does he land, so that's delta dx equal to VIX delta t, 1/2 AX delta t squared, and it's this term that goes to 0 this time. So delta dx is equal to VIX 2.8 meters per second times 2.6 seconds. Delta dx is equal to 7.28 meters. You can't get an easier one than that. Number 3, a dart player. So he's firing a dart. And the height is 1.8 meters above the ground. And of course, as it travels, it loses a bit of its height, and it ends up hitting the board, which is 1.54 meters above the ground. And the question wants to know how far away is the player. Okay, so in the x direction, it tells us VIX is 12.4 meters per second. And we know AX is 0. We're looking for delta dx, and we don't know delta t. In the y direction, VIY is 0. AY is 9.81 meters per second squared. And our delta dy, we have to subtract these two, and we get 0.32 meters when we do. And everything's going down, so down can be positive, and we don't know delta t. So again, you're going to start in the y direction. So delta dy is equal to VIY, delta t, 1/2 AY delta t squared. VIY goes to 0, rearrange for t squared, so 2 delta dy over A. So t squared is equal to 2 times the 0.32 meters divided by 9.81 meters per second squared. Take the square root, get 0.2554 seconds. Then go to delta dx is equal to VIX delta t, 1/2 AX delta t squared. The AX term goes to 0. So delta dx equals, the VIX was 12.4 meters per second times the 0.2554 seconds we just found, and you get a delta dx of 3.167 meters. Okay, number 3. Number 4. So number 4 is a ground-to-ground projectile. It's a cannonball. It's being fired at an angle of 45 degrees with the horizontal initial velocity of 200 meters per second. So VI is 200 meters per second. It's going to go up and come down. This angle is 45 degrees. This is my VIX. This is my VIY. And it says, that's it. And it wants to know, I'm going to get the glare off this. That didn't help at all. It wants to know how long is it in the air, maximum height. Okay, so in the x direction, VIX is equal to VI cos theta, which we could find. AX is equal to 0. We don't know delta dx. They want us to find it. We don't know delta t. In the y direction, VIY is equal to VI sine theta. Going up, we can get that. We have that value. AY is 9.81 meters per second squared down. Sorry, I'm still trying to get the glare off here for you. And that's it. But when it's ground to ground like this, the key is to look at just the first half. And when we look at the first half, the VY here will be 0. And so we look at AY is equal to VFY minus VIY over delta T. But if we're looking at just the first half, the VFY is 0 and this is TU. So delta TU will equal negative VI sine theta over AY. So it'll be equal to negative 200 meters per second sine of 45 over negative 9.81 meters per second squared. And we will get a TU to be 14.43 seconds. That's TU, so our delta T then will be 28.86 seconds, which is the answer to part A. Part B wants to know what is the maximum height. So we're looking for delta dy max. Going to run out of time.